Lesson 9.1, Adding and Subtracting Polynomials. We have some vocabulary words I want to discuss right now, and then we'll get into it more depth later on. A monomial is an expression that is a number, a variable, or a product of a number and one or more variables. The degree of a polynomial is the sum of the exponents of its variables. The polynomial is a monomial, or the sum or difference of two or more monomials. Standard form of a polynomial means that the degrees of its monomial terms decrease from left to right, which we'll discuss more when we start writing them in standard form. And the degree of a polynomial is in one variable is the same as the degree of the monomial with the greatest exponent, which we'll discuss in a couple minutes too when we do our homework. If you look on the left-hand side up at the top, I wrote a box for you. You might want to pause and write these two boxes I wrote at the top for you. We have some terms that we need to discuss when we're writing out the names of polynomials. We use the number of terms to name a polynomial. So a polynomial that does not have any adding or subtraction and it's all just multiplying, that's a one term, and that polynomial is called a monomial. If you have two terms with an addition or a subtraction sign in the middle, that's a two-term program, and that's a binomial. You also have a three-term, which is, I showed you here, which is this 3x squared plus 3x plus 3. That's three-term, and that's a trinomial. And then you have just a number. A number also can be a polynomial, and that's also a one term, and it's called a monomial. If you look on your right-hand side, we have the names of degrees that a polynomial can be. If you have an exponent of 1, and if I can show you right here, it's a hidden 1, it's an exponent of 1. You look at just that, and it's a degree of 1 degree. And so that degree, the name of the polynomial is a linear polynomial. If you have a exponent of 2 on a variable, it is a 2 degree, and that's called a quadratic equation or polynomial. If you have an exponent of 3, the degree is 3, and it's called a cubic polynomial. And if you have an exponent of 4 or above, you are going to have what's called the 4th degree. If it's an exponent of 5, it's the 5th degree, so forth and so on when it comes to the number, the variable, the exponent you have on there. If you do not have a variable, but you have a number, there isn't an exponent for the variable, so it would be 0, and that would be called a constant. Let's try out some examples on the next page. Example 1. Find the degree of each monomial. So first of all, you're going to add up all the exponents on each of the variables. Well, there's only one variable on A, and the exponent is 1. So you're going to add up 1 plus, there's nothing else, so you're going to say 1. That's the finding the degree. That's all you're going to do on that one. On B, though, there are 2 variables and there are 2 exponents. So you're going to take the 2 and the 3 and you're going to add them together. And you go 2 plus 3 is 5, and there is your answer for the number of degrees for this one. And then C, like I said, you have a number and it does not have a variable. So it's a hidden 0 and a hidden variable. So it would be the degree would be 0. Now example 2. This is a little different. We're going to write each polynomial in standard form. So that's step 1 on this. So you're going to take the variables and find their highest exponent. Well, this one is the only number with a variable, so we're going to start with that number and you're going to put negative 2x, because you always start with even the sign in front of it, which this one would be a minus sign or a negative 2x, and then you put plus 5. We'll come back to naming the expressions in a second. On B, we have the highest variables are to the 4th power, but also we have 2 of them, so we need to put them together, put like terms together. We've been discussing this for a while. You put like terms together to come up with your answer. So you're going to go 3x to the 4th plus 5x to the 4th. Well, 3 plus 5 is 8, and do not change the exponent. So we're finished with that. And then we find the next highest exponent, which would be x squared. So you're going to add it and go 2 plus 2x squared. And last is the minus 4. C. Again, we're looking for the highest exponent, which would be y to the 3rd, but remember to keep your minus sign with it, so it would be negative y cubed. And the next x variable is 3y, so we'll do this one. So we'll go plus 3y, and last is 4. Now we're going to name it based on the degree. So first of all, we're going to look at the exponent. Well, the exponent is 1, that's my highest. And if we look at the naming of a degree with 1, that would be linear. And then we were going to find the number of terms, and if you look, the number of terms is 1 and 2. We have 2 terms, so it would be, and 2 terms is a binomial, so we're going to go binomial. And that's all you're writing down for this answer. If we look at B, the exponent would be 4. So that would be, if you look at the 4 and above, remember is 4th degree, 5th degree, 6th degree. So this one would be 4th degree. And we have 3, so that would be a trinomial. And if we look at the third one, we have an exponent of 3 is my highest. So if you look at the 3rd degree, that would be cubic. And again, there are 3 terms, 1, 2, 3. So that would be also a trinomial. For your knowledge, if you have 4 or more terms for your polynomial, you'll write down polynomial with And then how many terms do you have? If you have 4 terms, you would say with 4 terms. If you have 5 terms, you would say with 5 terms. So depending on, I forgot the more right here. 4 or more terms. All right. Next example. We're going to simplify each sum, and then we'll do simplify each difference. So first of all, you're going to add like terms together. So you have 4x squared plus 2x squared. Remember, you're not changing the variables, you're just changing the numbers in front. So 4 plus 2 is 6, and then you put x squared. And remember, we would like them in order from least to greatest, so we want them in standard form. And then the next one would be, we're done with those, positive 6x plus negative 9. So we go 6 plus negative 9, which would be negative 3x. And then last is 7 plus 1. So 7 plus 1, it's 8. If we have B, we have 12m plus 8m squared. That would be 20m squared. And then 4 plus 5, which is 9. Subtraction, same idea, except sometimes you're going to have a negative negative. So that's going to change it. So you're going to go 2x cubed minus 1. There's a hidden 1 there. 1x cubed, which would be 1x cubed. Or you can take away the 1. And then you have 5x squared minus negative 8 squared. So right here you have 5 minus negative 8. Remember, you make them positive, so 5 plus 8, and that is 13. So that would be plus 13x squared. We do not have another x, so we're just looking at negative 3x, and that's it. So it's minus 3x. And then you have left is minus positive 11, which would be minus 11. And there's your answer. And it's in standard form. D cubed. You have 30d cubed minus 2d cubed. Minus, remember, right here, minus. So it would be 28d cubed. Then we have d squared, negative 29d squared plus minus negative 1d squared. Remember, negative 29 minus 1 would be negative 30d squared. And what's left over is minus 3d, which would be minus 3d. All right. And that is the end. Goodbye.